New pictures got by the James Webb Space Telescope have staggered experts. Rather than expanding our perspective on the universe, these photos uncovered a disturbing reality. Our constant comprehension is lacking in making sense of the possible results of the universe in its starting stages. Where the theory of the Big Bang seems to show up at its limits, this drives us to contemplate new theories about its beginnings. The request arises as for how the universe was formed exhaustively, and why this new exposure moves even the most experienced experts to figure out more about the Big Bang and the complicated nuances of the disclosure. Could we review the possibility of the Big Bang itself in scorn of standard thinking? The Big Bang was not an impact in past space. Rather, it was space itself that started around 13.8 billion years ago, close by issue and time. A characteristic in material science and cosmology describes centers where gravity is extraordinary to the point that the curve of space-time becomes infinite. Today, following billions of years since the beginning of the universe, we see that our tremendous home is part of a grand cycle. For experts, this tends to a vital piece of the universe since its very existence. It's clearly a perpetual development. However, it's crucial to get a handle on that the universe isn't drifting into past space. Perhaps space itself is steadily stretching out in size. As per current theories, the first stars started to shine somewhere in the range of 200 to 300 million years after the Big Bang, marking the completion of the alleged Dark Ages. This was a place where the first glowing celestial objects coalesced to form mature systems. However, the way in which quickly these galactic systems formed remains a frustrating mystery. An overflow of data emerged through the first pictures caught by the James Webb Space Telescope in July 2022. Experts uncovered that the telescope had identified different galactic systems, some of which had already existed around 300 million years after the development of the universe. However, rather than the vast designs formed much later, these early universes were out and out more humble and less immense. This aligns perfectly with the scientific model accepted by experts. The density of issue in the early universe was simply not sufficient to bring about universes the size of those observed today. What began as the identification of 6 glowing, red-shifted spots from the James Webb Telescope ended up triggering potentially the most critical cosmic discoveries in recent times. Although these newly found universes are similar in age to recently recorded universes, they are generally about as extensive as our own Milky Way. This has created an enthralling mystery in large assessments. Subsequent to analyzing a series of images obtained by the near-infrared camera, experts identified the aforementioned light sources using redshift to confirm that the light from these objects required more than 1 billion years to reach our eyes on Earth. Thus, we are dealing with structures that had previously existed around 570 million years after the initial Big Bang. By analyzing the properties of these formations, it was concluded that the Webb telescope had captured 6 early universes in the photos. Shockingly, these universes were so gigantic that they challenged typical assumptions in cosmology. Instead of finding the typical more modest universes, structures were identified that were nearly as large as our own Milky Way, despite having formed early in the universe's history. Assuming we continue to examine the data collected by the James Webb Telescope, this gravitationally bound bundle of stars was at that point more than 10 billion times the mass of the Sun. At that time, one might even have outshone the 10 billion solar mass mark. However, whether the situation is accepted, the mystery remains disrupted without a doubt. Even for this case, there would be significantly more stellar mass in the early universe than previously expected. This presents a problem. The identified objects contradict basically all traditional cosmological theories. Whether only one of these astronomical systems proves to be genuine, it would challenge our previous assumptions. Moreover, the density of issue in the early universe would have to be a few times more substantial than previously expected to account for this anomaly. Another commonly strange explanation depends on how these infinite systems formed in such a way that remains totally obscure to us. These discoveries and the discussion surrounding the Big Bang have prompted various scientists to drift away from this theory. Different astrophysicists with alternative points of view feel their perspectives are not being heard in scientific journals. Even those who express doubts about existing theories are often labeled as ridiculous or misguided. Yet clearly, even experts who still advocate for the theory of how things came to be are continually confronted with questions without definitive answers. These inquiries include specific issues like why and how, 13.8 billion years ago, something literally emerged from nothing. Might something truly begin from nothing? Or was there some triggering event? Or was it all a mishap? Steven Weinberg pointed out that the concept of time, as we understand it, began only with the Big Bang. Thus, this process could not have been triggered by something outside it. A similar contentious question relates to the consistency of radiation and density throughout the universe. No matter which direction or at what distance we look on a larger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Normal analysts explain this quirk through the theory of cosmic evolution. However, several experts take this assumption further with a theory of turbulent evolution. According to this thinking, evolution has only halted in specific regions, like bubbles, and continues endlessly elsewhere. This suggests that different universes could be forming in these bubbles, each with its own unique physical rules. Within this model, a simple question arises: what if the universe doesn't represent the whole picture? More intriguingly, consider how plausible it is that another universe existed before our own. In this case, the Big Bang would become part of a larger cycle. According to this viewpoint, our universe is part of a more distinct multiverse. Inside this framework, the idea of an undying pattern of breakdown and renewal of the universe is advanced. However, this isn't the only perspective presented in the realm of cosmology. In addition to the theory of the universe's origins in 1955, for example, an article appeared in NASA Space Times arguing that there might have never been a Big Bang, since the universe has existed for an infinite amount of time. In this view, the expansion of the universe would be non-existent, and the consistent arrangement of matter could give the impression of a steady evolution. Moreover, another captivating hypothesis arises from the domain of quantum physics and string theory. Some experiments have suggested that our universe, and everything in it, could just be a flat three-dimensional image projected onto a surface. Thus, there is a plausible thought that our existence is a result of a higher dimensional simulation. While this might sound like the plot of an intricate science fiction film, it could indeed be connected to the Kardashev scale, which measures the level of advancement of a civilization based on its ability to harness energy. If there were a Type 3 civilization able to completely harness the power of an entire universe, it could have created a perfect simulation. Getting it right in such a situation is a bright, tangled matter. Exploring the depths of cosmology and the origins of our universe leads us into a realm of immense mystery and ongoing scientific inquiry. The new pictures obtained by the James Webb Space Telescope have reignited debates about the true nature of our reality, testing established theories and prompting scientists to rethink fundamental pieces of cosmological understanding. At the core of this inquiry lies the theory of how things came to be, a cornerstone of current cosmology. According to this theory, around 13.8 billion years ago, the universe emerged from a remarkably dense and hot state, rapidly expanding and resulting in space-time and matter as we understand it today. This immense event wasn't just an impact within past space. Rather, it could involve the very origin of space itself. The concept of a singularity, where gravitational forces are so extreme that space-time becomes infinite, supports our understanding of this early stage. However, the discovery of early systems by the James Webb Telescope challenges our assumptions about how quickly structures formed in the universe's earliest stages. These systems, identified within a few 100 million years of the Big Bang, appear astoundingly advanced and massive, contrary to expectations based on current cosmological models. One of the key questions raised by these findings is the concept of rapid expansion, as indicated by the inflationary theory. According to this theory, development occurred within fractions of a second after the Big Bang, causing the universe to grow dramatically. This rapid expansion would explain the uniformity of the cosmic microwave background radiation observed across the universe today. However, the new discoveries suggest complexities in the early universe's development that may require adjustments to inflationary models. The development of systems like those observed by the Webb telescope compels cosmologists to reevaluate the conditions and processes governing the universe's initial evolution. These vast systems, now enormous in size and mass, imply a density of matter that exceeds previous estimates. The mystery persists as we consider how such colossal formations could have shaped and evolved in a relatively short cosmic time period. Beyond the discovery of these early systems, further research is needed to unlock the secrets of our universe's origin. Beyond the discovery of these early systems, further research is needed to unlock the secrets of our universe's origin. As scientists continue to analyze the data from the James Webb Space Telescope, they are confronted with puzzles that may reshape our understanding of the cosmos. The images captured by the telescope provide a glimpse into a period of cosmic history that was previously hidden from us, revealing not only the size and complexity of early galaxies, but also challenging existing cosmological models. The discovery of these unexpectedly large and well-formed systems so early in the universe's history raises fundamental questions about how quickly structure could emerge after the Big Bang. If these early galaxies could form so rapidly, it suggests that our previous models of galaxy formation and evolution may need to be revised. The fact that such massive structures were already present in the universe's infancy also raises new questions about the nature of dark matter, the role of gravity in galaxy formation, and how the first stars and black holes shaped the early universe. The implications of these discoveries extend beyond the realm of pure science, touching on our very understanding of time, space, and existence. If the Big Bang is not the definitive origin of everything, but rather part of a larger, cyclical process, what does that mean for our understanding of the universe's future? Could there be a universe before ours? Are we part of a multiverse, where different laws of physics govern different domains? These questions, once the domain of speculative philosophy, are now at the forefront of scientific inquiry. Many scientists are now considering alternative models that go beyond the traditional Big Bang theory. For example, the concept of a multiverse suggests that our universe might be just one of many, each with its own distinct physical properties. In such a model, the events we observe, the expansion, the formation of galaxies, the birth of stars, could be just one iteration of an ongoing process. A universe might collapse, only to be reborn in a new form, with different physical constants or entirely different laws of nature. These models challenge the notion that our universe is the only one, or that its beginning was a one-time event. One of the more fascinating possibilities is the idea that our universe exists as a simulation, a creation of a highly advanced civilization, as some theorists suggest. This idea, drawn from the realms of quantum physics and string theory, posits that our universe could be a projection from a higher dimensional space, akin to a computer-generated simulation. If this were the case, it could imply that the entire universe as we perceive it might not be real in the traditional sense. Instead, we could be part of a sophisticated system, running on a higher level of reality. While this idea may sound like science fiction, it touches on important questions about the nature of existence and reality itself. Could the laws of physics that govern our universe simply be the result of computational processes? Could time and space, as we understand them, be artificial constructs? These are profound questions that touch on the deepest aspects of philosophy and physics, and the answers may lie in the further study of phenomena that we have only begun to explore. The future of cosmology looks set to be an exciting and revolutionary journey, with the James Webb Space Telescope playing a crucial role in unlocking the mysteries of the universe. As scientists sift through the data, they will no doubt continue to make groundbreaking discoveries that could change our view of the cosmos forever. Whether these revelations will support the current Big Bang theory, lead to new models, or prompt a complete rethink of the origins of the universe, the journey is only beginning. In the end, The search for answers to these fundamental questions about the universe's origin is more than just a scientific endeavor. It is a quest that has captivated human imagination for centuries. As we peer deeper into the universe, we are reminded of our own place in it and how much we still have to learn. The discoveries made by the James Webb Space Telescope are only the beginning of a new chapter in our understanding of the cosmos, and the answers to these profound questions may yet be far beyond what we can imagine.